Okay then, we've looked at the constituents of the modulator. We're going to, in a minute, go through to the modulation enclosure and see what's in there. But just to get in there, we need to gain access from this panel here. At the moment it is unlocked, but we need to get one of these keys out. These are called Castell keys. This one's got a number inside. It says 93 on it, etched, engraved inside. And it's such that when you put it in, it locks with the ident on the other side. So 93 fits with 93. You can't get 95 to go in there. I've already got a key here in the door, so we can open the door, go in through, and this is the sort of oily, smelly type area where the transformers live. The mains transformer, actually 2S because there are two of them, are here. These take 11 kV, 11,000 volts AC from the national grid, and drop it down to about 10,000 or 9,000 volts. Two of them, and we feed the 9,000 volts or so via these copper bars here through to a solid state rectifier, which replaced a mercury arc rectifier. So it's a solid state rectifier just the other side of the door, which then generates the DC. So that's the mains transformers. The power from the modulator arrives, here's one of them coming in from one of the modulation anodes onto one terminal of the modulation transformer. Across here is the other, and there's a centre tap where the 11 kV, 11,000 volts DC starts here. Notice we've got an earth wand on it. If you're watching in the States, it's a shorting stick in your country, but it's an earthing wand in the UK. It's often said that when transmitter staff retire, they hang up their earthing wand. That's one of the standard phrases. So that's the modulation transformer. Various bits of protection here, ball gaps for flashovers, and metrosils, which are like voltage-controlled resistors. Big voltage, it'll just shatter, but it will save the windings in the transformer. Just looking through here, we can see three large capacitors on the floor, a set of three. These are modulation blocking capacitors and are from one connection of the mod transformer to earth. The other connection up to the HT line is made by this reactor, which is here. It's always a reactor in the States, a choke in the UK. This is a low frequency reactor. It allows us to pass the DC through the reactor to the secondary of the mod transformer. The audio power gets superimposed on the DC, which then flows out to the tubes. The DC is prevented from flowing through the modulation transformer secondary by the capacitors on the ground. It's a standard way of doing it. If you just look through there, you'll see some more some more capacitors and some chokes, some smoothing chokes. There for the power supply smoothing for the regular 11,000 volt DC. We're looking to get 11,000 volts at about 50 or 60 amps. So we're looking for about a 600 kilowatts power load of HT at maximum modulation. You'll see some Jennings switches on the wall. These switch resistance mats out, inrush protection. There they are. Behind that and up to the high level is the air blast cooling department to generate the air that blows through the cubicles. And right above here we have one more vacuum switch with a large wire attached to it. It's got HT on one side, HV on one side, and a big fat green and yellow wire on the other. That's a crowbar switch that when we turn the transmitter off, that shorts out any HT that's left in the system. So that's the crowbar switch on the main HT. That's one you don't want to fail when it's running program. Okay, and so we've looked at the modulation enclosure. Let's just come out again and look at some of the coils that we use for the various frequencies. This is an anode coil here for the 9 megahertz band, 31 meter band. Looking down here, there's an anode coil for 21 megahertz band. It's behind the door. Collection of coils. Here's a coupling coil for 12 megahertz and an anode coil behind it with another one as well, both for 12 megahertz on the final stage. These heavier construction ones, here's a pen anode coil for 12 megahertz and a coupling coil into the final stage for 6 megahertz. Far more turns on that one. The ubiquitous stepped bar enables us to connect to a preset, a fixed coil that's already mounted in the transmitter for the lower frequencies, for 9, 7, 6 and 4 megahertz. So that's that.